Okay, we're going to dive right into this and talk a little bit about gearing. Now, we're not going to get into everything gears. What we are going to do is talk a little bit about spur gears and the properties of the involute curve. All right, first things first. What is the involute curve? That's a curve in which gears are designed and cut. Okay, and we're talking about the imperial system. We're talking about our system here in the United States. Most all of the metric is done off of a module. All right, we're not going to get into that today. There's a lot of similarities, but we're not going to dive into all that. But we are going to talk about the nomenclature of the gear teeth. That way we have an idea of when we pick up a gear, what are all the parts, and is it really that complicated? Well, it is and it isn't. All right, so first thing is if you take a look at this diagram, it really looks complicated. There's a base of circle line for the pinion, the pitch circle, the addendum, the dedendum, the root, the fillet, the circular tooth. We're not going to go that deep into it. And the reason being is because there's a few basic things that we want to discuss just to get you some level of familiarity with gears. All right, so for the labs that we're going to be working with, you need to know a few basic things. Now, we do need to understand that there's all these parts, but we really want to boil it down and try to really oversimplify spur gears and say that there's a few things you need, starting off with the large P, which is diametral pitch. Okay, what is diametral pitch and why do I need it? First of all, it's the number of teeth to each inch of pitch diameter. Okay, or it's the ratio of the number of teeth to the number of inches in the pitch diameter on the plane of rotation. Okay, what does all that mean? Well, really what it means is that, so for these two gear sets to mesh, the distance between these teeth have to be the same on this gear and this gear, regardless of what the diameter is. Okay, so let's get back to this over here. This keeps the spacing the same between each tooth for matching gears. So if you have one gear set that has really big teeth and another gear set that has small teeth, and you try to put them together, they're not going to match. Okay, they need to have the same size teeth, regardless if it has the same number of teeth, because that doesn't really matter. This, as long as the teeth size and spacing are the same on each one, you can get away with that. Now, how we end up finding that. Now, look, it's there's a lot of different ways to find it. There's a lot of different formulas of which we can use, but the main one that we're going to talk about here is finding the diametral pitch, okay, because that's going to be the basis for matching our gears up. What we need to know is the number of teeth. We can easily count those, okay? And then we're going to add 2 to that, and we're going to do that math first, and then we're going to divide it by D and subscript O. Now, what is D and subscript O? That is going to be your outside diameter. So that's really easy. We can take the gear, we can take a set of calipers, we've already learned that lesson, and we can measure that outside diameter. And then what we can do is count the number of teeth. Let's say it's 20, we'll add 2 to it, so it's going to be 22 divided by that outside diameter, and then it's going to give you that big P, and that is going to give you, again, the ratio of the number of teeth to the number of inches in the pitch diameter. Now, pitch diameter is the next very important thing that we need to know, and that's going to be represented as a big D in these formulas, and it's the diameter of the pitch circle, or, okay, hear me out, the operating pitch diameter is the pitch diameter in which the gear operates. All right, so when we go and put those two gears together, if you would, this is the circle that represents the actual pitch. Like it's not the outside diameter in which that is used for calculating ratios. It's actually that circle in there. Now, let's back up a few here, and we're going to talk about this. You see this pitch, you see this line, this dotted line here, and you see this dotted line here that's about in the middle of the tooth. That right there is representative of the pitch circle. So that is going to be what's used to do your calculations from. Now, so how do we get this pitch diameter or the diameter of the pitch circle? All right, well, that's very simple. The big D, pitch diameter, or the pitch circle diameter, is going to be equal to N, which is the number of teeth, okay, divided by the diametral pitch. So as you can see, it's important to get the diametral pitch with the things that we have, okay? It's very simple. We get the diametral pitch. And then we can get the pitch diameter, and now we know that circle, and now we can start calculating ratios. Yes, you can calculate ratios on number of teeth, but the pitch diameter is really what you want to know in order to have that. Now, once you have these numbers here, it opens up a whole world of things that you can calculate based upon the natural functions of the involute curve. Well, we're not going to get into that, but we are going to talk about a few other things very quickly. We're going to talk about pressure angle, okay? What is pressure angle and why do I need to know it? Now, What the pressure angle is really it's in the angle. So if we imagine there's a big gear here and a big gear here, and we draw a straight line between those two axes, okay, and then we see what the angle of the tooth, how it's pressing on the other tooth, that is the pressure angle. Now, in the other diagrams, you can see that the pressure angle is here, but then you got to do more math and do it by 90. I thought this was a great representation of what it looks like. Again, you're drawing a straight line, the center of this gear through the center of this gear, and where they're actually moving, the direction of tooth push, okay, that's this is the angle in which it's actually pushing, or called the line of action, very important to know. And then if you take a look at the center to center here, then you can see what angle the teeth are actually pushing at, and that's going to be your pressure angle. Now, why does that matter? Because there's multiple pressure angles. There's 10, 20, 30, 40. Well, maybe not so much that, but hear me out. There's at least this many, okay? And so to keep it simple, if it's a 10 degree, okay, you're going to notice that it looks a little bit more straight up. If it's 20, okay, it's got a little bit more to it. And if it's 30, it's going to be a little bit more pointy. Now, even if your diametral pitch is the same, you're going to have some issues if your pressure angles are going to be a little different. So pressure angle is something else that's very important when setting up gear sets. Now, the last thing that we're going to talk about very briefly is backlash. What is backlash? It's best represented by what you see right here. Okay, these teeth are coming together. Now, if those teeth were coming together and there was zero clearance, so there was no room, you're going to feel like a bump, 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 bump as each one of those teeth come in there. That's going to be friction. That's going to be, it's going to make it not smooth. It's going to generate heat. It's going to generate wear. So there is a certain amount of backlash that actually should be in the gear set. And generally, if everything is designed and cut perfectly, there won't really be a backlash, but usually the gear teeth are thinned just ever so slightly to allow that additional space right here, okay? Now, how much space is appropriate? Let's take a look at this chart over here. This can actually be found also in the Machinery's Handbook, wonderful publication. Let's take a look. So normal diametral pitch range, 20 through 45. We're going to pretend that we're, we're going to pretend that we're 25 or so. We can take a look over here to the resulting approximate backlash, and it's 4 to 8 thousandths. Okay, so generally speaking, this is kind of sort of what we're looking at as far as that. There is a calculation for it, but we're going to keep it simple. We're going to use charts to figure out, hey, what are we working with, and then we know how much this needs to be. Now, in a lab that we're going to be doing here very shortly, we're going to talk about how to actually measure this. What we're going to do is we're going to set up a dial indicator, okay? And we're going to put that dial indicator right here, and then we're going to have that dial, and then we're going to be able to hold this gear tight and then move this gear back and forth and read exactly what that looks like, okay? All right, so this wraps up this particular section. Now you know a little bit more about some of the gear attributes that are very, very important to this, and we're going to follow up with the next part of the lab.